Why are graveyard orbits used for satellites? Imagine a busy highway filled with cars, some of which have broken down or are no longer in use. If these cars stayed on the main road, accidents and traffic jams would happen. The same idea applies to space. When satellites reach the end of their lives, they need a safe place to go. That's where graveyard orbits come into play. These special spots are located a few hundred kilometers above the geostationary orbit, which is about 35,786 kilometers above Earth's equator. Moving old satellites into these higher orbits helps keep the main satellite lanes clear for active satellites. It also prevents crashes that could create thousands of tiny pieces of space junk. These fragments can be dangerous because they travel at very high speeds and can damage working satellites or even spacecraft carrying astronauts. Moving satellites into graveyard orbits is much easier on fuel than bringing them back into Earth's atmosphere. For geostationary satellites, deorbiting requires about 1,500 meters per second of velocity change, which uses a lot of fuel. Shifting them into a graveyard orbit only needs about 11 meters per second. That small amount of fuel makes a big difference in cost and effort. The geostationary belt is very important for things like weather forecasting, television signals, and communication services. Keeping this area free from dead satellites helps prevent interference and keeps these services running smoothly. International guidelines recommend moving non-functioning satellites away from active zones to reduce space debris. The process involves carefully controlling the satellite's speed and orientation to transfer it into the designated graveyard orbit. This maneuver requires precise timing and reliable attitude control systems. Overall, graveyard orbits are a practical solution to manage space junk, protect active satellites, and keep Earth's orbital environment sustainable for future space missions. This approach helps us keep space safer and more organized, ensuring that satellite systems and orbital dynamics continue to serve us well.